This is Tech Math 2, and we're in section 11-3 and 11-4 today. And we're dealing with the law of cosines and then applications where we have to use both. So unlike the law of sines, where I had a nifty proof to show you that it's true, I really don't have one of those for law of cosines. So law of cosines, and if we have a triangle, and that looks sort of like a, well, it's really bad. Let's see if I can find a real triangle. Oh, there we go. So if I have a real triangle, oh, that's kind of nice. And I got an A and a B and a C and a little a and a little b and a little c. And it's not a right triangle. If it's a right triangle, I'm not going to use this at all. Then I can say that a squared is going to be b squared plus c squared minus 2bc cosine a. And I can say that b squared is going to be a squared plus b squared minus 2ab cosine b. And I can say that c squared is equal to a squared, who did that? A squared, c squared, that's better. As I was saying, b squared minus 2ab cosine c. So whatever I have on the left-hand side of the cos of the equal sign, I have everything else to the right-hand side except for the capital of the one on the left-hand side. Well, that was pretty cool. Now, I'm only going to use this when I have to. So when I have a situation where I know I have a side angle side, so I've got two sides in that angle. So I know A, and I know little b, and I know little c. Well, I can't use the law of cosines, because the law of cosines say I have A over sine A is equal to B over sine B is equal to C over sine C. And no matter what I do, I have two missing things. So I got one equation, two unknowns. I have one equation, two unknowns. I've got one equation, two unknowns. So I can't solve it using the law of sines. So if I have a situation where I know side, angle, side, I have to use the law of cosines. The same thing is also true if I have a situation where I know all three sides. So I've got all three sides of the triangle. I know A, I know B, I know C. Well, the law of sines isn't going to work again because I still have one equation, two unknowns whenever I do it. Now, if we had more than an hour of the class, I could go and take the law of sines equations in multiple forms and derive the law of cosines from it. But no one would care, so we're not going to do that. All right, so we'll use the law of cosines when we have to, but then we'll revert to the law of sines because of the less chance of making a mistake in my calculator. Okay, so that's the plan. And we'll start with number 3. And number 3, we have some triangle. Might look like that. And I don't know what A is, but I have 140 kilometers over here. And I have 3 significant digits. I don't know what B is, but I have 215 kilometers over there. And I know that C is 109.0 degrees. Now, unlike in the law of sines, where you could have an ambiguous case where you could have two solutions. That is never going to happen to you ever when you're using the law of cosines. The law of cosines will give you a answer. That's the answer, period, the end. You don't have to go looking for another one, which is, I know, very much a relief situation for Ben over there, who's worried about that considerably. All right, so we have a situation where we have side, angle, side, so I have to use the law of cosines to solve the problem. And so now the issue is, what are we going to look for? Well, we're going to look for C, because if I go C squared is equal to A squared plus B squared minus 2AB cosine C, I know all of those guys. Those are all knowns to me, and I'm only solving for C. All right. So that being the case, C is going to be equal to, normally we'd say plus or minus the square root, but it doesn't make any sense to have a negative number, so we're not going to do that. Square root of 140 squared plus 215 squared minus 2 times 140, 215 cosine 109. And now it's just a matter of, can I put it in my calculator and get the right answer, or will I fat finger some key and mess it up? So square root of 140 squared plus 215 squared minus 140 times 215 times cosine 109, and hit the enter button, and I end up that C is 274.9999, so we're going to call that 275 kilometers. All right, well, once I know that C is 275 kilometers, now I can find, using the law of sines, one of the other angles. So 275 divided by the sine of 109 has to equal, we'll use 140, 140 over sine A, implying that A is equal to the arc sine of 140 sine 109 divided by 275. Arc sine 140 times sine 109 divided by 275, close parentheses. I end up with my A being 28.8 degrees. I then subtract 180 minus that answer, minus the 109, and I end up with B being 42.2 degrees. And now I'm done. There's my A, my B, and I already solved my C up there.
See, I got 292.2.
Let's see if I can still have that in my calculator. 274.5 square root of 140. Okay, I can't see the whole number, so I can't see. It looks like I put it in my calculator right. I'll put it in again, but it looks like I put it in right. So square root of 140 squared plus 215 squared minus 140 times 215 times the cosine of 109. Now I still get 275. So I have to get out of my chair and look at the calculator. Oh, am I in radians?
Well, I was in degrees.
You're in degrees.
I got retyping it out. I take out my stuff.
Yeah. So the issue is, no, I can't be in radians. No, I'm in degrees. Yeah. No, I did it twice with the same answer. Anybody get my answer? No one? Anybody gets Nate's answer? You got Nate's answer? All right, well, on second opinion, my calculator did not put, I didn't put that 2 in my calculator, so this should be 292. Is that what you're telling me? 292 kilometers, which means that has to be 292 kilometers, which means that if I take the arc sine 140 times sine 109 divided by 292, I end up with 26.9 maybe, or you might want to call it 27, it's hard to say. And then 180 minus the answer, minus 109, this gives this guy here should be 44.0. Okay, sure, I'm glad I figured out I didn't put in the 2 after looking at it 3 times. All right, looking at number 11 next. All right, well, I've got a triangle and all I have are sides. So I've got 7,000 meters to 2 significant digits and 5,600 meters to 2 significant digits and 4,800 meters to 2 significant digits. So now the issue is we have to solve for A, B, and C. All right, so we'll go with A first. Okay, so if I have A squared is equal to B squared plus C squared minus 2A BC. BC cosine A, then I get that A is going to be the arc cosine of A squared minus B squared minus C squared divided by minus 2BC. And let's see if I can put that in my calculator without messing it up too bad. All right, so arc cosine of A, 7,000 squared, minus B, 56. Oh, I did it already, I only put 700. 7,000 squared minus 5,600 squared minus 4,800 squared. Oh, bummer. I didn't put parentheses around it. All right, going all the way back, clearing the entire entry and starting over again. Arc cosine, parentheses, 7,000 squared minus 5,600 squared minus 4,800 squared, close parentheses, divided by, and we'll put parentheses around it again, minus 2 times B, 5,600 times C, 4,800, close parentheses, equals, and I get A is going to be 84.2 degrees. I really can't do that. I really have to call it 84. So my final answer is going to be 84 degrees because I only have 2 significant digits in my length. All right, now that I know that the A divided by the sine of 84.2, I can keep it there, is equal to 4,800 divided by the sine of C. Sine of C? Yeah, sine of C. So C is the arc sine of 4,800 sine 84.2 divided by 7,000. All right, so I'm going to go arc sine 4,800 times the sine, second function answer, close parentheses, divided by 7,000, close parentheses, equal. So I'm going to have 43 degrees. Well, if C is 43 degrees and A is 84 degrees, 80 whatever degrees, then B has to be 180 minus 84 minus 43, the other 43, 53 degrees. So now I got my answers: B, there's C, there's A. But I'm only going to do that if I have side, 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 or I'm side, angle, side. Now I could have gone and used the law of cosines again to find the other angle, right? I could have done that. I just chose not to. Because too many, as you hit more keys, you end up getting more wrong answers, right? I don't even have to hit more or less keys for that matter. Either way, it works fine. 18. Well, at least we have enough significant digits in 18, don't we? Okay, so I've got 111.05 degrees. I've got 1976 feet. I've got 3250 feet. And I want to know B, I want to know C, I want to know little a. So over here I'll put down little a is equal, C is equal, B is equal, and then that's where I'll put my answer. Alright, so I want to find little a first. So little a is going to be square root of 1976 squared plus 3250 squared minus the 2 I left out last time, 1976, 3250 cosine 111.05 degrees. Okay, now assuming I can put it in my calculator without making a mistake, 1976 squared plus 3250 squared minus 2 times 1976 times 2350 times cosine 111.05. Close parentheses again, and I get that my A is 4368 feet. An answer only a surveyor would like, right? An electronics kid would be more than happy with 4,400. But I have 4 significant digits, so that's what I need to write. All right, now that I know that, I have to find the other guys. So I'm going to go 4360 divided by the sine of 111.05 has to equal something. We'll use 3250. 3250 divided by sine C. C will be equal to arc sine of. Okay, do some cross multiplication. 3250 sine 111.05 divided by, what's your problem now?
I come up with 2919, not 4268.
2919. Okay, so I got to move all the way to there. Okay. So what do I see? Cosine is right. Oh, bummer. I didn't square the 3250. No, I'm not supposed to square the 3250.
No, I didn't square the 3250.
Oh, you didn't square the 3250. All right. Yeah, I squared. Yeah, no, I got it in my calculator right. So
Yeah, 46. All right.
I got it. I lucked out.
Yeah.
All right. All right. Well, you know, if you don't have luck, you don't have anything right. Back to what I was doing. What was I doing? I was taking the arc sine of 3250 times the sine of 111.05 divided by 4386, close parentheses, equals. And I have lots of significant digits, right? So I'm going to have to call it 43.98 degrees. Okay, so up here, 43.98 degrees. Okay, so now I want C. 180 minus my answer I just got, minus 111.05, and I end up with 24.97 degrees as my C. Now, who's going to measure something to 24.97 degrees? Yeah, only the architects and the civil guys, right? We would never do it. We'd never say our phase angle is 24.97 degrees of phase angle, right? We'd never do that. All right, 28. Now, Wyatt, you look worried. Are you worried? You're not worried? Okay. All right. You're looking sort of worried over there, and I just wondered, This isn't the first time you saw the law of cosines, right? Yeah, exactly. So you quit looking worried. So we're going to do 28. I should just pay attention to what I'm doing and not pay attention to the class. Okay, no problem. All right, so what do we got here? We got some triangle. Looks sort of like an isosceles triangle. So I got Q and I have S. And I've got 18.5 something feet on this side. But I also have 18.5 feet on the other side. And then up here, I've got some R. So this is an isosceles triangle. And I have 22 degrees there, and I have 22 degrees there. Well, what am I supposed to do? Find side OS. Well, all right, or QS. Find side QS. Okay, so QS is equal to, why would I even bother to use the law of sines or cosines to do that? I would just say that QS is going to be 2 times, now there's just a side opposite, right? So the sine of 22 is equal to 18.5 divided by the side opposite, OBS. Okay, so this is going to be 18.5 divided by sine 22. And I would just use right triangle trig. That's pretty cheap, but that's what I would do. I imagine they want us to use the law of cosines because we have two sides in the included angle, right? But not being one of those types to be stuck with tradition or anything. All that can't be. I've got a 99. I got a 98.8. Is that right? 98.8. Yeah, that doesn't seem right. And I want to find the angle RSQ. Well, if I know that's 22, then I know RSQ is going to be 90 minus 22, which is, what, 68? Wow, that was a pretty lame problem. Now, if we use the law of cosine, it would have said A is the square root of 18.5 squared plus 18.5 18.5 squared minus 2 times 2 times 18.5 because they're the same times the cosine of 44. And that better equal 98.8, otherwise I'll be very displeased. But it can't be equal to 98.8. There's no way. Wow. What did I do wrong? Oh. Oh, God. Ben's choking on that over there. Where's my red marker? There we go. As I was saying, the sine of 22 is the side opposite over the hypotenuse, as I was saying. And I clearly said that earlier, right?
Yes.
Clearly it did. So I've got 2 times, I just wrote it down backwards for some reason. So this is 18.5 times the sine of 22. And now I got a new answer.
Well, how do you know the other one's 22 down?
It's a right it's an isosceles triangle. It can't be any other way, because if RS is equal to RQ, then I have 2 equal sides of a triangle. I have an isosceles triangle. The altitude of an isosceles triangle is the angle bisector.
Okay.
Yeah. You remember that from someplace, I imagine.
Yeah.
Yeah. 18. Now that I reminded you.
Yeah.
I normally don't make these things up, but you know. Okay, that's better. 13.9. All right, so 13.9. When I get down here, this had better be 13.9. All right, so, you got 25 square root of 18.5 squared plus 18.5 squared minus 4 times 18.5 times cosine 44, close parentheses, boom, 25.1 is 25.1 feet. Now, why can't I get 21 why can't I get that up here? I don't understand. Why am I bearing this cross that I shouldn't have to bear? 2 times 18.5 times sine 22, close parentheses. Yep, getting the same thing. Oh well. So you don't like that answer. Okay, well, neither do I. I wonder what I'm doing wrong. Did I wake up this morning? Yeah, I guess so. Anyway, so I'm going to go with that answer. Yeah, but I'm still going to go with this guy here, because clearly I can't do anything other than that. Okay. Now we're moving on to section 11.4. And in 11.4, we have applications. All right. So we get to choose what we want to use to solve the application. And there's 4 of them. That means I got 4 minutes per problem. Okay, so we'll start with number 3. We want to find the distance C across the pond. All right, so I got a pond. I got a distance C, and I know I got 49 degrees there, and I've got 81.3 meters here, and I've got 67.5 meters there, and clearly I can use the law of cosine, so I just will. 81.3 squared, 67.5 squared, minus 2. 81.3, 67.5, cosine 49. And the first problem should be done before I can get it into my calculator. And the pond is 62.8 meters across. 62.8 meters, final answer. Alright, well that was okay. I didn't have to do much there. Number 8. The physics book has a cool problem where the right fielder has to catch the ball and it's hit at some angle, at some velocity, and you end up having to use a lot of cosines and sines twice. And anyway, you have days like that. 8. The angle at 1/4 of a triangle line. Okay, so here I am. I'm sitting here and I got some angle. And it's 65.5 degrees. If the sides that meet at this corner measure 225 and 320, what is the third side? Okay, so this third side is going to be the square root of 225 squared plus 320 squared minus 2 times 225, 320 cosine 65.5 degrees. Another problem that we didn't have to think about. Just wait until we get to 11. Look at 11, I don't believe it. Square root of 225 squared plus 320 squared minus 2 times 225 times, that's a times there, Doug, 225 times 320 times cosine 65.5, couple sets of parentheses. So the other side is going to be 305 meters. Okay, well, that was another one done. Number 11. All right, from a point A, the elevation to the top of a cliff is that. And from point B, the elevation to the top of the cliff is that. Point A and point B are that far apart. Isn't that lovely? Find the height of the cliff. All right. So I've got this picture, looks like that, 37 degrees, 24 degrees, and this guy's 270 feet. Wouldn't it be cool to have this side? Wouldn't it be cool to know that side? Okay, so if this is 370, that's 370. What's over there? So 180 minus 37 gives us 143. If this is 143, what's this angle up there? Alright, so 180 minus 143 minus 24, that's 13 degrees up there. Alright, so that being the case, I know that 270 divided by the sine of 13 is going to be circle divided by the sine of 24, clearly implying that circle is equal to 270 times sine 24 divided by sine 13. So circle's 488 feet. So now I know that this is 488 feet, and I know that this is a right triangle, and I know that the sine of 37 has to equal 488 feet. Oh, I did it again. Has to equal the height, which is the side opposite, divided by the hypotenuse, which is 488. All right, so the height of the cliff is going to be 488 sine 37. 488 times sine 37. 293.68 feet. And then I asked myself, I only have two significant digits, 293 feet for my final answer. All right, now why didn't we do number 10, the vertical tower on the non-slope thingy? Oh, I know why, because that's going to be on your next test, so we wouldn't want to do that now. 22, we have all these cool problems, and we're going to do 22. Okay. A dental building. A dental building? Who picked this problem set anyway? All right, so 22. We have a dental building is a regular pentagon. Anybody know what a regular pentagon is? Yeah, anyway. Oh, that's just so cool. It's not that. That's not a regular pentagon. I wonder if I can go and get a regular pentagon. Oh, look at that. I can have a regular pentagon. Isn't that awesome? All right, now that I have a regular pentagon, I can tell you for a fact that this is 2, 2, 4, and 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 that's 2, 2, 4. So I know all that. And I probably know that in a regular pentagon, clearly the interior angle of a regular pentagon is 108 degrees. So I know that from my 10th grade geometry class. So I remember that from 10th grade geometry class. So I have 108 degrees here. Either that or from the bottom print, in small print in the book there where it tells me that. Those are the two good places. I'm gonna claim I remember it from 8th grade, from 10th grade geometry. Okay, so now I know that. I got those things. All right, so the issue is I want to know, this is A, B, C, D, and E. So before the end of the hour, I want to know the length from A to D. And then I got something here in the middle too. So I want to know A to D. And then I want to know A to N. A to N, where'd N go? Oh, N, I got a middle here. Oh, bummer. And then I want to know A to N. And then I want to find A to M. Okay, so those are the only things I want to do. Well, the A to D, that sounds easy, so I'll do that first. And go A to D. All right, so that's just A to D, square root of 224 squared plus 224 squared plus minus. That's a minus sign. I just know it is. Oh, thank you very much. 224 squared minus 2 times 224 times 224 times cosine 108. I don't have enough parentheses or something. All right, so square root of 224 squared plus 224 squared minus 2 times 2 times 224 times cosine 108. Okay, so that's going to be 117 feet, because I only have 3 significant digits. Okay, now I want what, who, where?
I got 362.
You got 362.
What do you, so what do you,
Okay, I got the cosine, I got the angle right. 224. Oh, you're, no, I don't think so.
I mean, I could be reread too. But
Yeah, it looks like I put it in right. Alright. 224, 224, 224. Everything's 224. Alright. Well, so there's some question of whether or not we're right. Alright, back to, we're going to calculate A to N. Alright, so obviously I got 1, 1, 2 over here, right? So on A to N is going to be square root of 2, 2, 4 squared plus 1, 1, 2 squared minus 2 times 2, 2, 4 times 1, 1, 2 times cosine 108. See if we can both get the same answers this time. All right, so square root of 2, 2, 4 squared plus 1, 1, 2 squared minus 2 times 2, 2, 4 times 1, 1, 2 times cosine 108 close parentheses again. Boom. I get 280. Yeah, 280 feet to 3 significant digits.
got that.
All right, so we're happy with that one. All right, so now how am I going to get the last guy, A to M? A to M.
You know, A to D.
Yeah, you know. Okay, so what you're saying is in order to get the last guy, I know that length, I know this length, and I know that this is a right triangle. Okay, so now this is just a squared plus b squared is equal to c squared, right? So I got that a to n squared plus 112 squared is equal to the only number that we disagree upon, 317 squared. So if 317 is wrong, I'm going to get this one wrong. All right, so I'm going to go back and redo 317. Square root of 224 squared plus 224 squared minus 2 times 224 times 224 times the cosine of 108. Oh, bummer. You guys got 362? All right. So I'm going to go back and say, see that I have 362 this time. It's 362 feet. Right, so if that's 362 feet, then this has to be 362 squared, implying that AN, all right, so it's going to be square root of 362 squared minus 112 squared, 344. 344 feet. A to M. 344 feet. And this is an M there, not an N.
That makes more sense.
All right. Happy with that? I still am disappointed that we didn't do the antenna problem hanging on the side of the mountain, but I'm sure that that'll be on either the next test or some homework problem. Well, these are all the homework problems, so it can't be that. All right, well, see you when I see you.